Up until now, we have dealt with linear functions, which means that if we have the x variable here and the y variable here, we can fit a straight line to the data. And this is the y hat, which is a function of the intercept plus the slope times the x variable. But what if the data tells us that this relationship is not linear, or that our intuition is such that we do not believe that this relationship is linear? Now we can consider where the population regression function is a non-linear function sorry, of the independent variables. That is, the expectation of y, given the values of the x variables, is a non-linear function of one or more of the x variables. So remember that a function f of x is linear if the slope here is constant over the range of x values, right? But if the slope depends on the value of the x value, then you have a non-linear relationship. So we are going to look into three different models of nonlinearity. The first one is interactions, where you have a multiplicative relationship between different x variables and the y variable. We want to look into logarithmic transformation of either the y variable, the x variable, or both. And we are going to look into polynomials, which are polynomial transformations of the x variables. So remember, this is important, that they are still functions of the unknown population parameters, the linear population parameters. Okay, so even if we have a function, for example, logarithmic transformation of y equals a intercept times or plus the slope of a transformation of the x variable, then these are still to the power of 1, so which means they are linear. So these coefficients, they are still linear. So we can use the ordinary least squares method to estimate such a model. And in general, when we want to look into which variables we want to include in our model, we should go to economic theory to decide what to include and what to exclude from our model. Whereas economic intuition should guide our decision of which functional form should our regression equation actually take. And if you look at data to decide what functional form to choose, you can use the Tukey's bulging rule. Which just gives you like a hint of what you can do with the data to make it linear. So for example, if you have this common like exponential relationship upward sloping relationship. You see here that if you go to increased values of x, then you have this increasingly steep curve, which means that if you take the logarithmic transform of the y variable, then this relationship will most probably become a linear relationship. And if you have other like patterns in your data, you can use these transforms to make your data linear, such that you can actually use the linear regression model on your data. So we'll talk about these in detail next time.